Hello and welcome to today's lesson. We're going to be covering topics under the Standard 2.2 C in Study in 6th grade, and then in Study Island we're going to be looking at the lesson entitled Estimate Solutions. So estimate is we're going to be using rounding rules for that. So you're going to want to take good notes on the rounding rules, and we're going to be looking at how to estimate fractions and decimals and how to estimate in word problems also. And as we're going through, make sure you're taking those notes, and if we go too fast, just pause and rewind, and that way you'll have a good resource to pull from when you're trying these problems on your own and when it's time to study. And you can even pause at the beginning of the question, work that question out, and then watch the video to see if we get the same answer. So glad that you're joining us today, and I hope you learned something new.
So when we're rounding, the general rounding rules are if you're going to look at the number you're going to round out and look at the next number to the right. And if that number is a 0, 1, 2, 3, or 4, you're going to round down. If that number is a 5, 6, 7, 8, or 9, you're going to round up. And so just the way little rhymes so you can remember that if you have trouble with that is find the number, look right next door. 5 or more, raise the score. 4 or less, let it rest. So that number is going to stay the same, is what let it rest means. And that's what rounding down is, keeping that number the same. So, and then we're also going to be looking at estimating with fractions. And so just a little tip with estimating with fractions in the middle here is use a common fraction as a way to estimate a calculation that involves fractions. So if you looked at or did the lesson on percent fractions and decimals, that second slide of notes is the common fractions, if you want to go back and look at that. But here's an example. So 5/16 can be approximated to 1/3 because 5/16 is close to 5/15. So you just change that denominator by 1, and that is equivalent to 1/3. So which of the following is equal to the sum in the addition problems? Approximately equal to. Approximately means you're going to estimate. So that means when I'm working with a fraction, if I can tweak the numerator or the denominator just a little bit, that's going to help me estimate. So if I tweak the first problem, if I tweak that numerator to a 5, that's going to be 5/5, which is the same as 1. And in my second fraction, 5/6, if I tweak that numerator to a 6, that's going to be 6/6, which is also 1, and 1 plus 1 is 2, so that answer is going to be approximately 2, which is choice A. So which of the following is approximately equal to the difference of the subtraction problem below? So once again, I'm working with the fractions, and approximately tells me that I can estimate. So when I look at 6/4, if I tweak the denominator down to a 3, 6/3 is going to be the same as 2, because typically we just want to bump the numerator down, denominator up 1 or down 1. We don't want to go any bigger than that when we're estimating fractions. We want to try to stick to. And so if I bump the denominator, the bottom down to 1, that's going to get us to a whole number 2. Whereas if I bump the numerator, so the top in the second fraction up 1, that's going to get me to 6/6, and 6/6 is 1, and so 2 minus 1 is 1, and that's going to be my final answer, D. So here I'm looking at a fraction, and if I look at 61, I know if I go down 1, that's going to be divisible by 4. So if I make that 61 a 60, I know that 60/4 reduces to 15, which is a whole number, which is what we're trying to get when we're estimating with fractions. And then when I have a 17/6, if I bump that 17 up 1 to an 18, that's going to be an 18/6. And 18/6 reduces to a whole number, which is 3. And that makes the division really easy because 3 goes into 15 5 times. 15 divided by 3 is 5, which is choice D, my final answer. Okay, so now we're looking at rounding to the nearest whole number. So that means when you're rounding to the nearest whole number, that means I'm wanting to round that first number there before the decimal. So that means if you remember that rhyme, I'm going to go next door, which is a 9, and that's bigger than 5, so I'm going to bump it up 1. So that means I'm going to bump this 3 that I'm looking at up to 4. Then you have to do the same for the second number. So once again, I'm looking at 6. That's the first number before the decimal. So that's what I'm going to be looking at to make it a whole number. And so that means I'm going to go next door to the 1, and that's less than 5. So I'm going to let it rest, which means that this is just going to stay a 6. So now that I've rounded those to whole numbers, I'm just going to take 4 plus 6, which is 10, and that's going to make A my final answer. So here I'm looking at rounding to the nearest whole number again. So that means I'm looking at the numbers before the decimal, which is a 6 and a 3 here. And when I'm looking to round, I go to the number next door, which the next door to the 6 is a 0. And that's less than 5, so I'm going to let the 6 rest. If I'm going back to that rhyme we wrote in our notes, this is just going to round to 6 as the whole number. And then I'm going to have minus. And then I look at the 3. And the number next door to that is a 2, and that's also less than 5, so I'm going to let the 3 rest, and it's going to stay a 3. So then 6 minus 3 is 3, and that's going to make E my final answer. Next, I'm going to look at some word problems in rounding. So here, Ricky went to the store and bought 9 boxes of apples. The lightest box weighed 40 pounds, and the heaviest box weighed 44 pounds. What could be the total weight of the apple boxes? So I know there's one box that's 40, one box that's 44, and the other 7 or somewhere in between that. So that means if I took all 9 boxes and multiplied them by 9, that would be, all of the weights would have to be bigger than that. So 0 times 9 is 0, 4 times 9 is 36. Since I know all of the boxes are 40 or bigger, I know that it can't be 360, but it's going to have to be bigger than that number. And so I'm going to do the same with 44. I'm going to take 44 times 9, and 4 times 9 is 36, and 4 times 9 is 36 plus the 3, and that's 39. So I know at least one of the boxes is 44. But some of them are going to be less than that too. So I know that the total weight is going to have to be less than 396. So that means my answer is going to be somewhere between 360 and 396. And when I go and look at my answer choices, the only number that is between those two numbers is A. Okay, 360 was a match, but because I know I have one that's 44 pounds, it can't be 360. It has to be bigger than 360, so it had to be A. So this problem here says that there's a CD player that you know costs $61.59. And your parents have offered to pay for 40% of that cost. So about how much money are they willing to give you? Because it says about, I know that I can estimate this problem. So when you're estimating money, it's typically best to round to the nearest 10, so like $50, $60, $70, especially because this is so close to $60. So I'm going to round that to 60, and then I'm going to take 40% of that. So remember, of means multiplication, so if I'm taking 60, if I'm finding 40% of 60, I'm going to be multiplying that. But to multiply by a percent, I have to first convert that to a decimal. So to do that, I'm going to move the decimal to the left 2 places, and this is going to become 0.40, or I can just write that as 0.4. So I'm going to multiply 60 times 0.4, and when I do that, I end up with 240, but remember I have to count up the number of numbers to the right of the decimal, so I have 0 in the top and 1 in the bottom, so that's a total of 1 in my answer. So the decimal is going to go right here. But it's money, so I always have 2 zeros or 2 numbers after the decimal. So that means they're going to give me approximately $24 to go towards the CD player. Hank reads 19 pages of his book each day. So what is the best estimate of total number of pages he reads in 25 days? So this 19 is pretty close to 20. So if he's reading approximately 20 each day for 25 days, I can go ahead and take 20 times 25. And having a 0 in the problem makes the problem go a lot faster. So 0 times 5 is 0, 10 times 5 is 10, and then I multiply everything by the 2, so it's going to be 0 and then 4, and then I add those, and that's going to be about an estimate of 500. So then I look for which problem has 500 falling between the two ranges. And when I look here, 500 isn't between 125 and 375. Here, 500 isn't between 875 and 1125, nor is it between two numbers in the thousands, but it is between 375 and 625. So D is going to be my final answer. Then my last problem here says 90 kids are in 6th grade at Paxton Middle School. 47 ride the bus every day to and from school. What is a good fraction to estimate how many kids ride the bus? So fractions are always part over whole. So part of the kids that ride the bus is the 47 out of the total 90. So this, when we're trying to add and subtract with fractions, we only wanted to bump it up or one and down. But here, because we are just reducing it, we can bump it a little bit more than that. So if I bump this 47 up to 50, making both of these answers end in 0, which means I can divide them both by 10 to divide and simplify it. And I can do that pretty quick by just dropping the zeros. And so that means it simplifies to about 5/9, which is going to be my final answer, which is C. So thank you for joining us today, and I hope you learned something new.